Good evening. Today I will discuss structural equation modeling. Also known as SWAYAM. It is little bit complex, advanced, and it requires knowledge of some other tools and techniques what already covered in this course, and I have partitioned this total lecture into three primary headings. One is today's introduction. So, today I will show you that what is structural equation modeling and how it is applicable to real life problem solving. Then also we will discuss that what are the components of structural equation modeling. For example, it consists of measurement model, it also consists of path model or structural model. So, we will elaborately discuss this measurement model in next class, then we go for path model discussions, and then there will be the model adequacy testing, and obviously I will discuss case study, one case study all through. Okay. That is why the today's lecture is introduction to structural equation modeling. Let us see that what are the prerequisites to structural equation modeling. You must know multiple regression, you must know path model, although I have not described path model till date, but within this system we will be describing path model. You must know confirmatory factor model, whose prerequisites is exploratory factor model. So, that unobserved variables is measured, can be measured through exploratory factor model. Now, what is the difference between confirmatory and exploratory factor model, that we have already discussed. So, that means if you know confirmatory factor model, you know path model, which is basically path model is the structural model, then you will be able to apprehend structural equation modeling. Let me recapitulate little bit of the prerequisites. I know that all of you have seen this type of pictorial representation for multiple regression, where y1 here y1 is affected by several variables, as well as y2 is also affected by the same sets of variables x1 to x3, and when there are more than one dependent variable, we have seen that multivariate regression is preferable. Now, question comes, if these variables are also correlated and the independent variables are also correlated, or if there is even the causal relationship between that y1 and y2, so what will happen? So, ultimately, in order to incorporate the covariance relationship between the x variables, so you create something like this, where x1, x2, x3, these three are the independent variable, y1, y2 dependent variable, but the difference of this structure with multivariate regression structure is that in multivariate regression you are assuming that x1, x2, x3 truly independent, they are not correlated, and there is no causal relationship between y1 and y2 also. But in path model, what you are making, you are considering that x1, x2 as well as x2 x3 or x1 x3, they can co-vary. And in addition, what we are saying that y2 can be affected by y1 also, in addition to the effect of x1 to x2 to x3. Okay. Now, let us see the equation for this path model. So, we are deriving equation for the given path model like this: x1 is a independent variable in this model, but correlated with other independent variables. So, that is basically this correlation can be captured through a matrix which is phi. If we can say this is 3 phi is a 3 cross 3 matrix, we can write like this. So, x1, x2, x3, x1, x2, x3, it is phi 1 1, then we can write phi 2 1, we can write phi 2 2, then we can write phi 3 1, phi 3 2 and phi 3 3. Definitely this is a symmetric matrix, and this will be phi 1 2, which is basically phi 2 1 equal to phi 2 1, then phi 1 3 is equal to phi 3 1, and phi 2 3 is equal to phi 3 2. And in case of multivariate and multiple regression, we have assumed that this is this structure, this off diagonal elements are 0. Okay. Now, we have considered here two independent variables y1 and y2, and we are assuming that x1, x2 and x3, they are affecting y1 with coefficient like this: gamma 1 is affected by 1, gamma 1 is affected by 2, gamma 1 is affected by 3. Similarly, from independent side point of view, this gamma 2 is affected by 1, that means y2 affected by y1, y2 affected by x2 and y2 affected by x3. Let me repeat here: y2 affected by x1, that is coefficient is gamma 2 1, y2 affected by x2, coefficient is gamma 2 2, y2 affected by this coefficient gamma 2 3. As these are regression line like equation, so this is having an error term. Now, this also will have an error term. In addition, here we are assuming that this y2 is also affected by y1. If this is the case, you have to give a symbol like beta y2 2 and y1 1, this is beta 2 1. So, if you want to write equation for this, then there are how many variables are there? How many variables are there? Different types. One set is dv's, that is y1 and y2. Another set is iv's, that is x1, x2, x3. Another set is errors, epsilon 1, epsilon 2. Then what type of relationships are available here? One relationship is like this. If you see that x1 to y1, this single arrow, this is known as causal relationship. Another type of relationship is giving here like this curved bidirectional. This is known as correlated relationship. Okay. So, these two types of relationships are available in, or these two types of relationship are estimated in path model. Okay. Now, if you want to write down the equations for this, so straight away we can write, one is dvh, my dvh I can write y1 and definitely y2 is there. This side also you can write dvh, you can write iv's, you can write errors. How many dv's are there? 2 dv's y1 and y2, x1, x2, x3. Okay, then error definitely this. So, the equations will be like this, y1 equal to, that y1 is not dependent on that y1 again, it is not like this. Similarly, if I see that y1 is dependent on x1, x2 and x3 and this error term, not y2. So, nothing will be written here, it will be straight away gamma 1 1, then x1, then plus gamma 1 2 x2 plus gamma 1 3 x3 plus epsilon 1. This is the regression equation for y1. Similarly, for y2, if we see that y2 is also affected by y1, so we can write here that beta 2 is affected by 1 y1 plus gamma 2 1 x1, gamma 2 2 x2, gamma 2 3 x3 plus epsilon 2. So, in matrix form you can write y1 equal to y2, then this side you see here it is nothing means 0 0 0. So, 0 0 beta 2 1 0, definitely again you are writing y1 and y2, which is the difference from regression model. Then here your gamma 1 1, gamma 1 2, gamma 1 3, gamma 2 1, gamma 2 2, gamma 2 3 into x1, x2, x3 plus you are getting epsilon 1, epsilon 2. This is your path model, or y equal to beta y plus gamma x plus epsilon. Beta y plus gamma x plus epsilon, and if you do little more manipulation, this will be I minus beta y equal to gamma x plus epsilon. Okay. Then further you may be interested to write this, that y, if I multiply I minus beta inverse here with I minus beta y, then I minus beta inverse, you are getting that gamma x plus epsilon, and this will be I. So, y equal to I minus beta inverse fx plus epsilon. The details of this, how to estimate this parameter beta, psi and all those things, epsilon, phi, all those things will be discussed under structural equation model. Under structural model of the structural equation modeling. Okay. So, let us assume that we know this for the time being, this type of relation is possible to understand. Then you come to confirmatory factor model. I think you can recollect yesterday's lecture, particularly I think last two lectures were on cluster analysis. Before that, then if I write like this, what you are doing here, in this case let us concentrate on only two factors and let they are related with x1, first one related with x1, x2, maybe second one related with x3, x4 and x5. There is definitely covariance between the two, that is phi 2 1, and each of the observed variables x1 are caused by this, caused by xi1 here, these are caused by xi2, xi1 and xi2. Now, if I write this one is lambda, then x1, for x1 I am writing 1, for xi1 I am writing 1 1, x1 affected by xi1, then lambda 2, x2 affected by xi2, then lambda 3 2, then lambda 4 2, then lambda 5 2. Okay. So, this one will be delta 1, this will be delta 2, this will be delta 3, this will be delta 4, this will be delta 5. And this is what you have seen in confirmatory factor analysis. We have written this one in this manner, that x1 equal to lambda 1 1 xi 1 plus delta 1, x2 equal to lambda 2 1 xi 1 plus delta 2, x3 equal to lambda 3 2 xi 2 plus delta 3, and x4 equal to lambda 4 2 xi 2 plus delta 4, x5 equal to lambda 5 2 xi 2 plus delta 5. So, resultant matrix you have written like this, your x1, x2, x3, x4, x5, this equal to your xi1, xi2 is there. So, write down lambda 1 1 0, lambda 2 1 0, then 0 lambda 3 2, 0 lambda 4 2, 0 lambda 5 2. So, this is 5 cross 1, this is your 5 cross 2, and then xi 1 and xi 2, this is 2 cross 1, then plus delta 1, delta 2, delta 3, delta 4, delta 5, this is 5 cross 1. So, resultant you can write Ax equal to, this is your lambda, this one is xi plus we can write delta. Okay. And if you recollect exploratory factor model, what we have written there, x minus mu equal to lambda f plus delta. It is coming similarly, only that minus mu is not there, but here also we assume that this subtraction is made, x is x minus mu, this subtraction is made. So, actually what happened, you are getting the same factor model. There is one difference in this case, the difference is in this exploratory factor model, what you have found out, when you found out that covariance of x, which is sigma, that one is lambda lambda transpose plus psi, because we assume that expected value of f transpose, this is I, that covariance between the factors. In this case, we are assuming that covariance of x is phi, depending on, so it will be, if there are p variables, it will be p cross p. So as a result, the covariance, here we are assuming covariance of xi, I am extremely sorry, covariance of xi, this one corresponds to this correspond to this. Okay, covariance of xi is this, then covariance of will be lambda expected value of xi transpose lambda transpose plus psi, which will be lambda phi lambda transpose plus psi. Okay. So for the time being, we stick to this only. Now question is how to estimate this lambda, phi and psi, all those things. With related to exploratory factor analysis, we have seen that how this can be estimated, but in exploratory factor analysis this phi matrix was not there, here phi matrix is there. We also will be discussing this under measurement model. So these two are very essential for structural equation modeling. Now see one big picture where we are doing like this. First let us think of that there is one variable eta 1, another variable eta 2, and these two variables are affected by some variables called xi 1, xi 2 and xi 3. Okay. Let the linkage be like this, eta 1 is affected by xi 1 as well as xi 2, and eta 2 is affected by xi 2 as well as xi 3, and eta 2 is also affected by eta 1. So under this condition, so I can, if you see the structure path model equation, so in path model equation, let me find out this path model. Yes, this is our path model equation. So if I keep side by side these two, keep side by side, so what is happening here? You see we are writing eta 1 in place of y 1, eta 2 in place of y 2, xi 1 in place of x 1, xi 2 in place of x 2, xi 3 in place of x 3, and here everything is linked with, all the x variable are linked with y 1. Here we are restricting that eta 1 is affected by xi 1, xi 2 and eta 2 is affected by these two. So that means this structure is similar to this structure, except the some of the links are omitted. Okay. So I can write this, that gamma 1, eta 1 is affected by xi 1 means gamma 1 1. So this one is gamma 1 2, then this is gamma 2 2, this is gamma 2 3, and this one is beta 2 affected by 1. The coefficient as usual we are writing here. Okay. Now the difference between this path model, what I have shown in path model in terms of y and x. When we talk about in terms of y and x, we say they are observables. Okay. Now when we are saying in terms of eta and xi, they are latent or unobservables or latent. That is the difference. So if this is the case, then what you require to do, you require to measure these unobservables or latent things. Okay. We will see this, but before that some more things, that these are covarying. Let me write, this is nothing but phi 2 1, this is my phi 3 2, this is my phi 3 1. the structure is there. Okay. So, as I told you that these eta and your xi, they are unimmeasurable, unobservable, latent, we require to measure this. How do we measure? We have seen earlier that our confirmatory factor analysis or exploratory factor analysis will help us to measure. What is this? These are latent, this is latent variable, this is also latent, these are manifest variables. So, these manifest variables are used to measure these latent variables. Now, we will do the same thing here. We may create here like this. Let we denote it as y1, this one as y2, here also to y3, y4, and definitely there will be error. That error will be suppose epsilon 1, this error is epsilon 2, this error is epsilon 3, this error is epsilon 4. So, arrowhead please give properly. Then what is the difference between this structure and this structure? If I place these two linking to 3 indicators variable, linking to 2 indicators variable, here eta 1 is linked with 2 indicator y variables, eta 2 is linked to the also 2 y variable. What we are saying? These two are latent, these are the manifest variables, and this eta 1 and eta 2 can be measured using this. This is nothing but a confirmatory factor analysis. This is what is confirmatory factor model. Fine. So, you can give a notation here. So, we have given lambda, I think let us use another subscript y, and this is 1 1, then this one will be lambda y 2 is affected by 1 2 1, then this will be lambda y 3 is affected by 2, this is lambda y 4 is affected by 2. So, we also require to measure this. So, let us assume that this can be measured by indicate a manifest variable x 1, then your x 2, then this is your x 3, this one x 4, then your x 5, x 6, and this side delta 1, this is your delta 2, this is delta 3, delta 4, delta 5, delta 6. Now, if you look into this side, what is there? Is there any difference between this? Between this and this? Here xi 1, xi 2, you have taken 3 latent variables, and these are the indicator 5 indicators, 2 are linked with xi 1 and 3 linked with xi 2. Here there are 6 indicators, 2 each are linked with xi 1, xi 2, xi 3. So, that means this is also a factor analysis part, a confirmatory part. So, then this one we can write like this, lambda we are taking as x 1 1, this is your lambda x 2 1, this is your lambda x 3 2, lambda x 4 2, lambda x 5 3, lambda x 6 3. Okay. What is missing here? I think if these are from confirmatory factor point of view, these are dependent, these are the causes, here these are dependent, this is causes. So, error terms given, but here from the path model point of view, these are the dependent side, this is the independent. So, you have to give some zeta. Okay. This is your This is what is known as in path diagram, this is known as structural equation model. Why it is structural equation model? Because the latent variables, they also have certain structure, some structural relationship is there. For example, xi 1 affecting eta 1, again eta 1 affecting eta 2. So, there is a structural path from xi 1 to xi, even though here xi 1 is not directly affecting eta 2, but xi 1 can have effect through eta 1 to eta 2. So, that means the relationship structure is correctly preserved. So, that is why this name structural equation modeling is given here. Okay. Now, the how to have the estimation of this is a big issue, and we will be describing later on that all these things. But here we want to, with this structure, I want to give you some names of the variables. In structural equation modeling, we will use the term like this: eta, all eta will be termed as endogenous variable. Endogenous. It is basically dependent latent. In the example given, this one is this eta, this is basically eta 1 and eta 2. Now, there is another variable which is xi, which is in this example, this is xi 1, xi 2, xi 3, which is known as exogenous variable, exogenous variables. This is independent latent. Okay. So, in general, there may be your m eta, that means eta can be m cross 1, xi can be n cross 1, that means n things will be there, or any other, instead of mn you can use something else also. Then we have y, which is in our case, in this example, y1, y2, y3 and y4. So, this is known as dependent manifest variable. It can be, so y can be p q cross 1. Similarly, you have x, here we have x1, x2 to x6, these are independent manifest variable. It can be xp cross 1. So, that means in totality you will be having p plus q manifest variables and m plus n latent variables. In addition, you have another variables like xi, other variables are in this case, for example, xi is a zeta. Zeta is nothing but the error terms, in this case it is zeta 1, zeta 2, it is related to eta. So, depending on the eta, if eta is m cross n, this also will be m cross, if eta m cross 1, m cross 1. Then another one is your epsilon, that will be related to epsilon 1, epsilon 2 to epsilon 4. In this case, this is related to your y. It all depends on what is the value of y. So, this will be same. Similarly, related to x, there is delta, that delta is your p cross 1 variable vector, this 3, and you have another parameters called phi, which is basically covariance of this. You will also will be getting psi, which is your covariance of your zeta. Okay, so there is a huge, very large number of your what I can say parameters to be estimated. Okay, fine. Let us assume that yes, everything is possible, and we are going for its stages. What is stage 1? Stage 1 is defining the individual constructs. What items are to be used as measured variables. Then stage 2, develop and specify the measurement model. What is the confirmatory factor model? Make measured variables with construct, draw a path diagram for the measured variables. Then stage 3, designing a study to produce empirical results. All multivariate modeling, as such any model building case, the design, study design is very important. Here what we are saying, assess the adequacy of sample size, select the estimation method and meshing data approach. This is true for multiple regression, multivariate regression, path model, factor analysis, principal component analysis, structural model, cluster model, everywhere it is applicable. Then assessing measurement model by validity. That means these first 4 stages we are talking about the measurement model. And then what is this measurement model? Measurement model is this part, this factor analysis part. This is your measurement side. Then what is your structural side? Structural side is this one. This one is structural. So first what we have, it is said that in these stages they find out the manifest variables, then develop the constructs and also measure this, the adequacy of this model. Then you have to see if the measurement model is valid, then you go through 5 to 6 that stages. If measurement model is invalid, then you have to redefine the measures and other things. Now specify, then your structural model is coming. Specify the structural model, convert measurement model to structural model. I think you have seen here. Ultimately, I will again repeat this. Then stage 6 is assess structural model validity. Then if structural model is valid, then draw substantive conclusion. If it is not valid, refine model and test with new data. Okay. In this case, what is it actually given? It is given in 2 stage model building. One is, first you develop the measurement model. First you develop the measurement model irrespective of your in this case, forget about the structural part. You have this many x variable, this many y variable, irrespective of eta and xi, you first go for one measurement model, where you will basically factorize, confirmatorily you factorize this eta 1, eta 2, xi 1, xi 2, xi 3 from y 1 to y 4 and this is the first step. And once you are happy with this, so that means if I just follow this one, this side it is my x is lambda x xi plus delta. This is my measurement model for this side, and this side will be lambda y equal to lambda y into eta plus epsilon. This is my confirmatory path. But your process of model building stage is that that you go for measurement model first, consider all this, then do a confirmatory factor analysis, find out the correlation or covariance structure of all the latent variables. Okay. See here, then once your all latent variables, everything is crystal clear, then you go for structural model. This structural model is the bit in between this path. This one you will do and you will estimate all those things. So, ultimately you will first prepare measurement model, then from the measurement model you get the covariance or correlation matrix for the latent variables. Using this correlation or covariance matrix, you will estimate the regression like coefficients or regression coefficients for this structural model. This is one. Second one is, you may be interested to do everything at a time. That means, you will feed the model when both structural and measurement part keeping intact at one go, but because of so many parameters to be estimated and so many permutation computation, what will happen ultimately, it is highly likely that you may get several offending estimates, and how to deal with offending estimates, it is a issue also in structural equation modeling. So, now what I will do, this is the structure I will show you. Already I have shown you, and these are the stages that what we have discussed. These equations also you have seen, x and y, these equations you have seen. Then the stage 4, that what matrix you are going to use. You have to choose one input type of matrix, that is correlation or covariance matrix. There are different assumptions, then your estimation technique to be used, process, computing power. These are the all stages, one by one you have to do. Then suppose like your regression model also, you have seen that regression equation is y equal to x beta plus epsilon. This is my model. Then what you have done, you have gone for estimation, that is your beta cap. Then you go on for goodness of fit or model adequacy, that is r square, f stat, r a square, all those things you have used. So, here also if I see that this my structural equation modeling, then are you not getting a structural the equation like this? The equation will be your first one, that eta 1, eta 2 in this case, and definitely here will be eta 1 and eta and xi and error, that path structure. Under this eta 1 and eta 2, if I write eta here, then xi 1, xi 2, xi 3, all those things. So, you have to write the equations. If I write for this particular model the equations, eta 1 is not affected by any of the teeth of 0 0. So, gamma 1 1 xi 1 plus gamma 1 2 xi 2 plus 0 plus zeta 1, and this one is beta 2 1 and this is 0, then this one is also 0 plus gamma 2 2 xi 2 plus gamma 2 3 xi 3 plus zeta 2. Then what is your matrix? Eta 1, eta 2 equal to 0 0 beta 2 1 0 eta 1 eta 2 plus you are getting gamma 1 1 gamma 1 2 0 0 gamma 2 2 gamma 2 3 into xi 1 xi 2 xi 3 plus zeta 1 zeta 2. That is my structural part. So, eta equal to beta eta plus gamma xi plus zeta. This is one equation. Another two equation is x equal to lambda x xi plus delta and y equal to lambda y eta plus epsilon. This is equation number 2, equation number 3. So, your model, this is my structural SEM model. Okay, and you require to estimate beta, gamma, then gamma x, lambda x, lambda y, covariance of this, covariance of this, covariance between of this. So many parameter you have to estimate. Second is parameter estimation. So we are not discussing here the detail of parameter estimation, and we will discuss later on separately. So once you have model, you require to know that what will be the goodness of fit measures. So my model is this, and I know that some way I will estimate all those things. Then I have to go for fit measures. There are three types of fit measures used in structural equation modeling. One is absolute fit indices, relative fit indices, and parsimonious fit indices. In absolute fit indices, the question is the residual or unexplained variance remaining after model fitting appreciable? They are absolute because they impose no baseline for any particular data set, similar to R square. R square, if it is 0.90, it says 90% variance of y is explained by the model. Here also we are basically talking about what will happen to this. Actually, although we will be describing in detail later on the estimation, what is observed with you is this is basically, if I how many y variables, y is q observed variables, x p observed variables, you have total p plus q observed variables. So, you have a covariance matrix of p plus q plus p plus q. So, this is the observed value and this is nothing but S, this is nothing but S. This is what is your observed. Now, using these equations, this eta x and y, this equation, you will also be able to estimate, or other way I can say fit this one, you can calculate this. Here if I use S, then it is S11, S12 like S, that PQ up to PQ, P plus Q. So, similar values you will be getting, and here instead of, now I am writing, instead of writing S, here we are writing the population sigma, then that will be in terms of your this beta, gamma, lambda x, lambda y. So, there will be they will be function of the. So, what I mean to say, we can find out the theta in nutshell. I am talking about that beta, gamma, lambda x, lambda y, like this. It is possible to frame this. Then this S and these are compared. There are several ways to compare this, but and then here p plus q into p plus q, this is the how many unique elements are there, that will be compared. When we initialize some value here, we will compare and finally get the value, and then based on this difference, when we fit something like this, this is total. Relative fit index addresses the question how well does a particular model do in explaining a set of observed data compared with other possible models. You can go for several models and then compare which one is your best. The reference one is null model, where we assume that there is no covariance values relationship in the y observed variables. Parsimonious fit index is similar to your adjusted R square, where it is number of parameters estimated are adjusted. There are different fit indices. I will show you one case here by 5 minutes of time. This is role of personnel and socio-technical factors in work injuries in mines, study based on employees' perception. This is published in Ergonomics Journal in 2008. So, we have captured several variables under personnel and socio-technical variables. Then what we have done, we have first gone for measurement model. All the manifest variable are used simultaneously, and then the latent variables are first latent variables are identified and linked to the manifest variable. Then confirmatory factor analysis was done, and the output of this confirmatory factor 1. This is the correlation matrix. This is what is the output. Once we get this output, and this is input to our structural model is this. So, first phase you have to identify the manifest variable and the latent constructs. Then you do confirmatory factor analysis, find out the correlation or covariance structure of the latent variables. Because in SEM your input is the either correlation or covariance structure. So, you for the measurement model you give the covariance or correlation structure, they will give you the latent correlation or covariance structure. Now, for structural model again use the latent correlation or covariance structure whatever you are getting from the latent variables, and then you fit like this. So, you will be getting picture like this. Then definitely these are the some issues what we may be discussing later on if time permits in other classes. And ultimately this is what is the observed correlation, this is factor measurement model, these are the fit of the measurement model that I told you that I will be discussing fully in the next class, and then the correlation among the constructs, and then your structural part, and these are the structural regression coefficients. Then you see whether the structural model is fit or not. If your structural model is fit, and go for interpreting the things. So, here ultimately there are several structural fit measures. Chi-square with 15 degrees of freedom value is this should be as small as possible. Root mean square is 0.06, this should be less than 0.05, less than or equal to 0.05, goodness of fit index is 0.87, 0.9 or more is better, means adequate, norm fit index it is, but these are almost 0.9. So, we can say the structural model is fitting the data. Similarly, we have also seen that the measurement model also fits the data. So, that means my model is fit very much to the data, and then using this structural equation model you will be also able to find out the total effect, that is direct effect plus indirect effect, and also you will be able to based on the effect you will be able to rank the variables. Okay. Now, what do we see that we found out that work hazard vis-a-vis work injury, work hazard has no direct effects in the model we have fit, but it has indirect effect and total effect is this, social support indirect effect this, safety environment indirect effect this and total effect this, job dissatisfaction direct effect and safety behavior this is the case. So, ultimately based on this total effect we are given the rank 1, 2, 3, 4, 5 like this. Similarly, as there are many dependent variables or dependent construct you can find out here. See, these are the exogenous, but all are this endogenous. So, for any of the endogenous variable you can find out that what are the direct and indirect effects. This will definitely help you in making better policy. Okay. Total effect. So, we calculated for this case work behavior, for work injury, for job dissatisfaction, what are the variables and what are their rank order. Okay. So, thank you very much.